The next and the last topic we discuss in this lesson is the wind load on the press masonry. As you can see, when the press masonry it not get the strength, so we need to concern about what is the safe height that we can put. Otherwise, it may be fall out, and the accident happen when the press masonry and where there is a wind, it will be collapsed. So let's consider one cross section of the gore when fresh. So you see the gore. Let the height of the gore is h, and then the thickness is t, and of course we talk about the wind load. So let have the wind applied. Assume it uniformly distributed on the surface of the gore. And that is a Q. That is Q. Then the gore weight at the center of mass of the gore, we call that a W. Then to be if we have that wind applied, then the gore, if it tipping, it will be tipping at the endpoint A. I'll show you there. If it tipping or overturn. So to be not tipping or overturning this press gore, we need to have the resistance moment have to be greater than or equal to the overturning moment. So the bottom line, we to maintain safety, we have the resisting moment, which is the weight of the gore moment, have to be greater than or equal to the overturning moment due to the wind. So resistance moment, as you can see, equal to, let me define the weight of the gore. And if we consider 1 unit, 1 linear foot, for example, then the weight of the gore, it will be equal to the unit weight, D, as defined below here, the weight of the gore per unit of the surface, times the height. Okay, so that what you have, this is the weight W. Let's write that first. We have a W times the moment about A, so it will be T over 2, as you can see there, T over 2. So that is the resistance moment, the weight times the thickness, T over 2, because that is the from the center of mass to A, center of gravity to A is T over 2, and have to be greater than the moment due to the load Q of the wind at A. So it, as you already know, in ancient mechanics, QH square over 2 QH equals equivalent concentrated load, and the H over 2, that is the moment amp. So we can get that equation. And W, if it define the D small is the weight of the gore per unit, and we time the height, then we can find out the weight in there. So it will be, rewrite D H T over 2 greater than Q H square over 2. And from that we have H. From that we have what? H is 2 cancel out. So the shape H here is less than or equal to D T over Q. And that equivalent to the maximum height, the safety, maximum safety height of the gore when we lay the bricks. So that is the maximum height we can do. We call it HS. S stands for safety. Okay, the safe height. dt over Q. How to determine D? How to determine Q? The thickness of the gore is given. How to determine? D, and Q. So for D, we go to table 14.4, and for Q, go to table 14.3. If I go to slide in here, so the 14.3 that give you the wind velocity, then you can be able to determine Q, which is the desired wind load, power per square foot, or kilopascal. And then the right, you have the table 14.4, and that determine the weight of go per unit of the surface for different time of go that you have it in there. And go to the reference. If you go to page number 2 of the final exam reference, we have that table as well. So let's go back to here to apply this problem in problem 5. Find the maximum safe unsupported height. So that basically the one that we talked earlier, that is HS, maximum safe unsupported height, in feet. For the 6-inch heavyweight concrete block, go if the maximum expected wind velocity is 60 miles per hour. So from that wheel, we can apply that equation immediately. That is HS, the maximum safe unsupported height for the fresh masonry, is equal to maximum, so it's equal to dt over q. And now we need to find out what is d, got is q, t given here, t given is that is t 6 inch that you have there. So with that, we go to table first, table 14.3, with the velocity 60 miles per hour. Then we can have what is q. To go to the reference here, 60 miles per hour. Then the velocity, the desired wind load, it will be 7 power per square foot. So here we can have that is 7 pound per square foot. And then we go to table 14.4, and in this case the heavyweight concrete block go. Then we can be able to determine the weight of the go per unit surface. So we have here heavyweight 6 inches heavyweight concrete block go. So let's go to that table. Heavyweight concrete block 6 inches. So you have 6 inches heavyweight concrete 6 inches. Then the D, the weight of per unit of go surface, 44 pound per square foot. So D, we have 44 pound per square foot. So all we already have. So plug in. We have the at edge, the safest, the maximum safe unsupported height for the fresh masonry without collapsing when you do the lay in the break. To plug in, we have D 44 times T. We have to convert that into 6 inches. So you have 6 inches. Or we have to divide by 12. So unit conversion. And then divide by Q, 7 pound per square inch. And the answer will be 3.1 and feet. So that is the maximum height you can do with algorithm. It will be collapsed due to the wind velocity is 6 miles per hour.